So hello everyone and welcome to my YouTube channel CodeCafe, and I'm Anshuman Nehru, currently working as a software engineer 1 at Elucian, and I'm really excited, really nervous to start this journey up, right? And so moving on to what we are going to do today, or what we are going to start from today, is so how are we going to build this journey is that we'll be breaking down data structure algorithm in small concepts, taking one concept one by one, understanding the patterns in that, and understanding how the logics are implemented using those algorithms, right? So that's one of the things that we'll be starting ahead. And this channel is open to everyone, not only to people who might know a bit of algorithms or people who are new to data structure algorithms. So it's open to everyone. And so whosoever is watching, just like, share and subscribe so that I get more motivation to go ahead and make such kind of videos for you guys. And okay, so the first topic that we are going to start ahead is backtracking and recursions, since those are the two topics which gives the essence of both brute force approach, and also it gives an essence of implementing recursions, in implementing getting the essence of how algorithms are implemented, right? So all two topics will all two like both the topics will be combined together. And my approach towards learning anything is, the more you solve, the more I won't be explaining you theory on backtracking much. I'll be starting with that. I'll be giving you the major understanding of what backtracking is, but the patterns, the approaches that we are going to use will be solved through questions. So the more questions you solve, the more revision you do, the more you could become the more better you are every day in data structure algorithm. That's what my approach is towards learning DSA. So I think like this is a good journey for me also to start, since it's been a while. I have also touched DSA, so this will be a good opportunity for me as well to start ahead and share my knowledge and keep be enthusiastic to teach and also at the same time learn, right? So okay, starting ahead with the backtracking concept that we have here. Okay, backtracking algorithm. So what do we understand by backtracking algorithm, right? I'll try to take a simple analogy, right? Imagine that we have 5 paths, or let's take 4 paths. Path A, path B, path C, and path D, right? We have 4 paths and we need to reach to a destination. We need to reach a destination. So we need to reach a destination. Let's take a time in 5 hours. In less than or equal to 5 hours, or we'll just keep in less than 5 hours, right? So how are we going to so what the question that I'm asking you, it's a puzzle, so just think about it, right? So I am asking you that give me the possible path that we can take up so that we are able to reach our destination in less than 5 hours, right? Pause the video, think about it, how you would have done if you would have been told in a real life scenario that you need to reach a destination in less than 5 hours, right? So I hope you guys thought about it. So moving on to the given analogy, right? Okay, so the most simple thing that comes to my mind is that, hey, let me take my car. Let me go on path A first. So point A is like, let's take a starting point. Starting point. I said, hey, I am going on path A, right? I am going on path A. I'm exploring that path. Midway, I understood that, hey, midway is just 50 minutes, so the other half, if I go on the constant speed, will give me, you know, probably if I reach the destination in 1 hour, right? I'll be reaching the destination in 1 hour, right? So let me just say that, hey, it will be 1 hour. So path A from the starting point will take you 1 hour to reach your destination. Now, but it's not like your solution is over, right? You need to check for the other paths as well. So what you do is you come back to the starting point. You come back to starting point. You say that, hey, I have covered that in 1 hour. You're like, okay, now let's check for the other one. Start again from the starting point. You say that, hey, I have path B. Okay, midway when you're traveling on path B, you realize that, hey, it's already I have reached 4 hours. I think the next half won't get covered in 5 hours, right? So you'll be like, path B is taking 6 hours, for example. In total you'll be like, hey, it's taking 6 hours, I cannot reach by 5 hours, right? Since we have a condition that we need to reach a destination less than 5 hours, the path should be only taken if we are reaching in 5 hours, right? So what we are doing is we're cutting half in the exploration, and we are saying that, hey, no, let's come back to the starting point, man. We cannot reach to that path, right? It's taking more than 5 hours, and you realize it halfway, right? You realize it halfway, saying that, hey, it's taking more than 5 hours and I cannot reach that. So hey, let's go back to the starting point. You come back to the starting point again, and you say that, hey, okay, we have one more path to explore. I have path C. You say that, hey, okay, this path is only taking around 1 hour halfway, and the other half we can cover it in 2 hours very clearly, right? So you say that, hey, okay, 2 hours, we have 2 hours, so it will be taking 2 hours to reach there, and you will be like, okay, it's taking me 2 hours. I have checked there that it's taking me 2 hours now. So I'm saying, okay, I'll be coming back to starting point, and we'll be exploring the last one in the similar manner. You say that, hey, path D won't, in halfway again you realize that it's taking more than 5 hours, so you're like, okay, come back. Okay, so you came back to your starting point again. Okay, so if you noticed here, right, you are exploring all the solutions basically. But if you already come to know that, hey, I won't be able to reach to that certain path in the given time, I will be coming back. I won't waste my more of the time to make it certain, right? You don't want to make it certain. That way you will be losing on your you will be losing on your petrol, or you'll be losing on your own patience and everything, right? So you will be like, okay, let me come back, let me not explore, let me not exhaust myself by exploring more of the what is it called, paths. Okay, now you came back, and you explored. So how many solutions did we get? Okay, this is path 1. Yeah, so that means path A is a solution that we are looking for. Is path B a solution? No, path B is also not a solution, so there won't be anything. Is path C a solution? Yes, path C is a solution, right? Now we have path D a solution? No, it's not. Let's just say that it takes around 7 hours. Okay, it takes around 7 hours. Come back, and we have path A and path C as our answer, saying that the possible paths that we can take to cover our destination in less than 5 hours is path A and path C. That means you are able to explore all the possibilities for your solutions, to get your solutions, right? So that's one of the things that we are doing. So the solution or the answer is equal to path A and path C, right? This is what backtracking is all about. Exploring the possibilities, rejecting midway the solution, discarding the solution that won't, or pruning the solution. pruning the solution that will be, taking a bit that you already know that won't become a solution basically for you. Pruning it, just trimming it off, saying that, hey, this is not the solution we need. Let's go back. Let's explore some other paths and see the path possibilities, right? Let's just branch out from there. Let's just not explore that path because you know that already you have a certain, intuition that, hey, you won't get it. You won't get the solution in that path. So let's just come back, right? So that's one of the core concepts of backtracking, where you are pruning or discarding the solutions which you will not be able to get, in the given condition. You are discarding it. You're not going to explore that possibilities, right? So that's what backtracking is. If I combine it, what backtracking means is that it's a brute force approach to explore all the possibilities and pruning the one or discarding the one which won't give you the required solution. Backtracking will always help you to discard those possibilities which won't be giving you the solutions. Again, I'm repeating, it will be discarding or pruning out, cutting the branch. I'll come back to what I mean by cutting the branch which won't give you the solution, discarding it, right? So that's one of the things that we will be doing in this question also, to make you understand, right, how we are doing it, how backtracking is getting implemented and why we are doing that solution, right? So that is one of the most important things to understand. First, what the algorithm does. Always try to take an analogy in real life. Try to take that algorithm, implement there and think, okay, like, why are we using this basically, right? Okay, so the second important thing that I want to tell you is that now how we are, like I said, like cutting the branch, right? Why did I say branch, right? So understanding, since you might have understood that we are branching out the possibilities, right? If we're going to path A, if we are on the starting point, we are going to path A, then path B, then path C, then path D. All those are not a linear explorations. That's the second thing. All these are not the linear explorations, right? Linear searching. It's not the linear searching, basically. Searching the solution is not linear here. Why? Imagine, starting point, path A, coming back to starting point. Where have you learned this? When you have a solution or a base case, you come back. I think you ate you, right? It's recursions, right? It's recursions that we always use. So what do we do there? Okay, hey, we are finding the we are finding the Fibonacci series. Okay, come back. F of 5, F of 2, F of 3, F of 1, or whatsoever it is, right? We'll be having there the base case. We will reach the base case and you will be like, okay, hey, we got the solution. Let's go back to our previous solution, right? That's what a recursion does, and that's what we are also doing here in this part, starting in the problem or in the analogy that I explained you. We're coming back to the starting point. It's not like we are directly jumping to path B. We are coming to starting point because from there we are measuring our time, right? So when we talk about exploring possibilities, we always talk about, branching out. We always talk about, the approach of recursions, right? We implement backtracking using recursions. I repeat again, if we implement backtracking using recursion, since the search of solution or pruning is done in a non-linear manner. Okay, so pruning or like any other solution that we are implementing is done in a non-linear manner. What do I mean by non-linear manner, right? I explained you. We have starting point, we are exploring path A, coming back to starting point again, going back to path B, then coming back to again there to starting point and going to path C, so on and so forth. We are making a huge tree out of it, right? For example, if I would have said that, hey, from path A there are more 2 paths that coming up. Okay, so you'll be like, okay, path A, we are going to path C, path D. Okay, where am I getting the more like for example, family tree, parents, children's parent, one girl, one boy, two boys, two girls, right? So that same way we are tracing out our possibilities, we are tracing out the solutions, right? We're tracing out all those things that we are getting. Okay, so that's what backtracking is all about. We are exploring the possibilities, right? We're exploring the possibilities using recursions, right, in a non-linear manner, pruning or discarding out the redundant solutions so that we save our time. That's why, again, as it's a brute force approach, we have to explore all the paths, and we realize in midway, or we get intuition, or because of the conditions, basically we get to know that, hey, this is not a solution that we're looking for. So that's what backtracking is all about. That's what backtracking does. And recursion, as I said, why recursions? Since we are exploring the possibilities, we will be using recursions to implement a backtracking algorithm, right? When I talk about possibilities, I talk about tracing, searching the solutions based on the conditions, basically. So that's what backtracking is all about, right? So we'll be talking more about the implementation of backtracking. What does it mean? How does it start? What do we need to do with it, right? So I hope you guys understood this much about backtracking, what it is. And in the next video, we are going to solve the combination sum problem, which will help you to understand more about how does and what does recursion do in backtracking, how recursions are implemented, and why did I say non-linear searching or non-linear solutions or non-linear possibilities, right? So that's one of the things that we'll be talking more about with the help of these questions, because I feel that if I talk more theoretical, you guys will get confused. So in this video, there will be an ending summary which I'll be giving you now. So you guys can quickly just revise with me what this example. We have 4 paths, need to reach to a destination in less than 5 hours. We got 2 paths, path A, path C. Halfway you realize that, hey, it's taking more time for us to reach, it's taking more than 5 hours. Okay, let's just not explore that path completely, let's prune it, let's discard it, let's come to the starting point again and explore the other paths, right? Talking about backtracking is nothing but it uses recursion, since the search or solution or pruning is done in a non-linear manner. Backtracking is a brute force algorithm. It's a brute force algorithm that will help you to understand or explore different solutions, different possible solutions, right? So wherever in a problem statement you will be having, right, just if I just talk about here, return list of all unique combinations or permutations or subsets, the possibilities. You guys can explore possibilities using backtracking and recursion. That's what it makes it easier, right? The possibilities. So I think that's enough for today, and I will let you guys just understand and let the backtracking concept sink in, so that you understand in more depth that what backtracking does, and take up some more analogies apart from this one which I came up with, and try to understand the algorithm. And if you guys have any doubts, please be free to comment. I'll make sure that you guys understand. I make sure that you guys are able to just do your things properly every day. And the most important thing is that keep revising, so that all these concepts are there in your head. It gets concrete in your head, right? So that's what is the aim. So sayonara guys, bye bye, namaste, and don't forget to like, share and subscribe this channel. And I hope you guys understood everything. Thank you. Bye bye.